So in this video, we're going to cover the last aspect inside the set of notes that we said we're going to talk about, which is correlation. So first of all, calculation-wise, we're never going to do the math to get correlation. We're always just going to get this value from StatCrunch. So I will be, of course, demoing how to actually get that value from StatCrunch as well. But first, let's talk about what this number is supposed to be telling us. So correlation is going to be labeled as the symbol R, and it measures the strength and direction of a linear relationship. So when we say linear, we're implying again a straight line. So what that means is if I have a curved relationship, correlation is not going to be a measure I would want to look at. It indicates how close the points are to our predicted line. Now when we talk predicted line, we are talking that y hat equals mx plus b equation that we talked about with regression. So it's measuring how close the points are to that line that we're putting over the data set. Correlation has to be between two values. It has to be between -1 and +1. It can also equal those values, but seldom will for our data sets. What a correlation of 1 would look like is I have my line and every single point would be on that line. So very seldom with real data are we going to have every point perfectly fall on a line. But so let's talk about what this number can tell us. First of all, you'll notice it can be both positive or negative. So the sign tells us the direction of the relationship. So is there a positive relationship or a negative relationship? That's what the sign will tell us. So basically the sign tells us the same thing that the sign of the slope tells us, if there's a positive or negative relationship. So you'll see over here with my little graph I drew, I have a positive slope, which is why my correlation here would be a +1. So what a correlation of -1 would look like is, again, everything would perfectly fall on that line, but now the slope would just be negative to go along with that one. So just what a correlation of -1 would look like. So really the sign is not giving us anything new that we didn't already know. However, where we fall on this spectrum between -1 and +1 gives me a lot of information. If I'm a value close to 0, because 0 of course is covered when I go from -1 to +1, that's going to give me a very weak relationship. Again, more specifically, a weak linear relationship. If I have a correlation that's either close to -1 or +1, again, the sign only tells me the direction. So if I'm on either extreme, that's going to be a strong relationship. So let's look at some graphs to understand what kind of correlation we would get. So on your note handout, there's 4 graphs here labeled A, B, C, and D. You'll first notice that none of them have every point perfectly fall on a line. The correlation values I'm going to give you came from StatCrunch, just so that you know where they're coming from. Now first, if I look at these 4 graphs, which one appears to have the strongest linear relationship? So I want one that if I put a straight line through the graph, which one would have the points closest to that line? Hopefully we would agree that graph A would have the strongest linear relationship. If I put this line here through my data, all those points are pretty darn close to it. Since it has a positive slope, I would expect a positive correlation. Because those points are very close to the line, I'm going to expect a correlation way out here, pretty darn close to +1. What we get from StatCrunch with this one is we get a correlation of positive 0.92. So it's a very strong positive linear relationship. Now looking at our 3 graphs remaining, which one now would have the points closest to a line? Well, you're probably between B and C is a little bit harder since there's not a line on there. So let me kind of imagine actually putting a line on there for you for comparison. Now again, I don't care if it's a positive relationship or a negative relationship, just which one is the strongest relationship. Well, it should be graph B. Some students will think it's graph C, and I think it's primarily because there's more data points, so more dots on this plot than there is on this one. But again, if you look at the actual distance, how close things are to the line, there's more points on here that are further from that line, making its correlation weaker than what we see in graph B. Now graph B has a negative slope, so I'm going to expect a negative correlation. It is not as strong as graph A. So although I'm expecting it to be over here, it's not going to be as close to -1 as this was to +1 because it's a weaker relationship than graph A. So graph B's correlation turned out to be -0.79. Negative again, just because my slope is negative. Now looking at my other 2 graphs, which one's going to have the strongest linear relationship? Well, we should say C, because although D has a relationship, it is not a straight line relationship. If I try to put a straight line on this graph, it's actually going to be more horizontal, and it's not fitting that data very well. The correlation in graph C, though, should be positive because it has a positive slope, but it's not near as strong as our positive relationship we saw up here in graph A with a positive slope. So it's going to be more toward the middle idea here. This one turned out to be a correlation of positive 0.61. So finally, graph D. Now first, hopefully we would all agree that we should not fit a straight line to that graph. However, StatCrunch will do whatever you ask it to do, so it will fit a straight line to that graph. It will give you a correlation. Because my line looks primarily horizontal, I'm going to expect pretty close to 0, because there's really not a positive or a negative slope attached to that one. So I'm going to expect a correlation quite close to 0. This one turned out to be slightly positive of 0.03. If you would like to have some fun with correlation, there's actually an applet in StatCrunch that can do this. If you look, there's something called here correlation by eye. So if you click on that, you can just get some randomly generated data. And so I can just really hit compute here, and it'll give me a nice little picture and these points that you can see on it, and you can try to guess the correlation. So like on this one, it doesn't look like it has a really strong relationship. The points are definitely not very close together. But it does look like primarily here there's a negative slope going on, but there's a couple of points down here. So I'm going to guess at first -0.2. And then I can check it, and it'll tell me if I'm close or not. And then I can actually show what the value turned out to be. And then so I can reset it, get a new one. Sorry, I'll just get a new one here. And we can guess this one. So this one has a more strong negative relationship going on. And I'll do one where I actually don't think it's going to be real close, just so you can see what it will look like. So it's going to tell you kind of a little hint, try a stronger correlation. So that means we're going to actually be closer to -1. Apparently it's even stronger, so let's try -0.8. Now we're within 0.1, and it'll show us what that relationship actually is. So you can kind of just play with getting some new graphs. So here's one with a positive slope. This one actually is pretty darn strong. I'm going to guess 0.93, and let's see what it was. All right, so that's just something you can do if you're having a harder time kind of guessing what that correlation is. It's a nice little applet out here in StatCrunch that you can do that with. Now let's talk about something related to correlation. It's called the coefficient of determination, or it's really just R squared. And it literally is our correlation that we have up here, and we square that value. So when we square any value, we can never get a negative value. So all of our values here are going to be between 0 and 1. Because of that, you're going to lose that information about the direction. Or what I mean is, by looking at just R squared, you will not be able to tell if it has a positive or a negative slope. However, hopefully you've already created a graph and calculated correlation, so you've already got the direction in a couple of other places. So losing that information is not the end of the world. What this new number will calculate for us is it indicates the strength of our model, not the appropriateness of the model. That is, you still want to make sure you are looking at a graph and making sure that a straight line is what you want. For example, suppose you graphed your data and it looked something like that. Now what I've tried to do here is so you can kind of see that there's a nice little curve going on to it. But as I said, StatCrunch will do what you ask it to do, so it's also going to be willing to fit a straight line to that data set. So actually there, the points are going to be pretty close to that line. I could see a pretty strong correlation. However, it's still not a very appropriate model because I can actually see I really should have fit more of a curved line to that data. What we like then about R squared that we do not get with correlation is a nice interpretation. Up here with correlation, what's considered strong versus weak? There's not really a nice cutoff that we always use. R squared has a nice interpretation that never changes. It tells us the percent of the variation, or if you like the word better, you could say that we're talking about variability here. Right, that's what we expect with a statistical question, is we expect some different values. So it's telling us basically the percent of that variability that happened in Y that we can explain just by looking at what X is. Now, you're probably still not feeling that comfortable with this coefficient of determination. So let's actually look at these values for a couple of our data sets and interpret them. So we're going to do this first for example 1. Example 1 was that test 1 and test 2 score. So here in StatCrunch, I've just manually entered in my data, so I just typed it in myself. Now the correlation and R squared are going to be in the same place where we actually got the slope and the intercept. So if I go to Stat, Regression, Simple Linear, plug in my X and my Y. I don't need to click any extra options, so I'm just going to hit Compute. We have tons of information, but what you'll see here is we have R and R squared. So there's our value of R, our correlation. There's our value of R squared. So I'm just going to first write those two numbers down here, and then we'll come back to our notes and interpret them. Alright, so our correlation was positive 0.9177. So of course the first thing I already noted there was that it was positive. And remember, if it's close to 1, that's a very, very strong relationship. So here it's pretty darn close to 1, so it's a very strong relationship. Now our R squared has a more specific interpretation. So the first thing I'm going to do is multiply this by 100% to get 84.21%. Now it's that percent of our variability in Y, which was test 2 scores, that can be explained by X, which was our test 1 scores. So about 84% of why the test 2 scores were different we can explain by looking at just what happened on test 1. Alright, let's do this for our other example where we're looking at the number of classes a student missed and their final exam score. So again, I just uploaded my data. This one I did not manually type. And I'm going to go to my stat, regression, simple linear. Here my X was my number of classes missed because we were trying to explain the final exam score. And this time here is my correlation and my R squared. So again, I'm just going to write those numbers down here first. So our correlation was negative 0.7409 and our R squared was 0.5489. And again, you'll never need to calculate those, as will always be in your StatCrunch output. Now, how would I interpret these? Well, the first one here is actually now a negative relationship, which again meant the more classes that you missed, generally the lower you scored on the final exam. Not too shocking. Now, how strong is it? Well, it's not as strong as the one up here because this is not as close to negative 1 as this one is to positive 1. But it's still definitely leaning toward that strong side, but not as strong. So I will call this moderately strong. Now maybe you can see where I'm saying there's a little of subjectivity on interpreting this. So when would I go from very strong to moderately strong? Again, there's not a cutoff here. I would only pretty much disagree with you if you said something about it being weak or very strong. But moderately strong, pretty strong, sort of strong, all of those pretty much are saying the same thing. Now with R squared, we're multiplying that by 100% first. So we're going to get 54.89%. And then again, it's of our variability in Y. Which variable was our Y again? Right, so that was our final exam scores. Can be explained by our X, which was number of classes missed. So some final things about regression, correlation in general here. The first one is that correlation does not prove causation. What I mean, just because there's a relationship between two things does not mean that the one is causing the other to happen. An example of this. One time I was looking at my grades, and the grades are sorted alphabetically by last name. And what I found is those that were lower in the alphabet had higher scores. Does that mean, though, that if you change your last name to Zimmerman, that's going to increase your grade? No. I mean, right, that just because there's a relationship going on between two things does not mean that one was causing the other to happen. Also, secondly, being careful about combining groups. So, for example, you might want to look at males and females separately to kind of see if there's really the same relationship or not. Being careful of nonlinear patterns. This is why we should always plot first. Make sure a straight line is the way to go before we go any further. Extrapolation, that was a word we talked about when doing regression. This is predicting far outside of the data. This was a bad thing to do. And then finally, just being careful of how outliers could influence the results that we got. So at this point, we have covered all of the new material for Chapter 4. So we'll be doing another example next time.